When we are multiplying with polynomials, if we multiply a polynomial times a polynomial, then we can't just distribute anymore. We have to double distribute. So we want to go, we'll go straight into the examples here. If we had this binomial, two terms, x plus 3, times this binomial, x plus 2, we can't just do a single distribution because there's really two going on. So let's say someone comes to the door and they say, can you pass out this paper to everyone in your class? And can you pass out this cookie or these cookies to everyone in your class? So you have to do two steps. You'd have to first take the first thing and pass it out to everything inside the quote class. So this is the this is what we're going to pass out the x to. So we do that first. X times x would be x squared. X times 2 would be 2x. So that's what you get when you pass out the x. But you also have to pass out a 3. So we do 3 times x would be 3x, and 3 times 2 would be 6. So it's called double distributing because you distribute the first term, and then you do the distribution again, but with a different term in this case, the 3. And then we have to look at that, and there are going to be terms that we can combine. So normally they'll be here in the middle. That doesn't happen every single time, but normally, and that was an addition there. So the x squared and the 6 will stay the same, but 2x plus 3x gives us 5x in the middle. All right? That's one way you can show it. Let me show you another way that you could distribute these. It's the same exact idea, we just show it a little differently. So we have another binomial times a binomial. We take the x and we pass it out to both, so we get x squared plus 7x. That's what I got when I passed out the x. Now when I pass out the negative 5, I get negative 5x. I'm going to stack that underneath the other x. And then negative 5 times 7 would be negative 35. So it's kind of like the horizontal addition and the vertical addition. So now they're stacked. The x squared comes down. 7x minus 5x would be 2x. And the negative 35 comes down. Now, in this particular problem, stacking it doesn't seem like it would save you any much less space or time. Excuse me. But in some other problems, I'll show you some larger problems where it gets a little more challenging and the stacking might be helpful. So I want you to try 2y plus 3 times 6y minus 7, and this one, 3b minus 2 and 6b plus 5. I want you to try those two on your own. Go ahead and push pause and then come back and check it. All right, so let's give it a shot. I've got 12y squared minus 14y plus 18y minus 21. So I get 12y squared plus 4y when I combine those minus 21. How'd you do? And if you wrote it horizontally, of course you're going to get the exact same answer. It doesn't matter if you stack or do it horizontally. This one, I get 18b squared plus 15b minus 12b minus 10. Sorry, forgot to change colors. Watch your signs. When you distribute, you have to make sure you always use a sign. That's why I circle it, positive 3, negative 5, positive 3, negative 2. If I circle it, I know that I'm distributing a negative 2, and I'm not ignoring that sign. We combine like terms here. We get 18b squared plus 3b minus 10. We're going to do two more together. Hopefully those went well. All right, I did one vertically stacked and the other one horizontally. Last two. This time we have a binomial, 4x plus 2 times a trinomial. And here's where the stacking really comes in handy. And then we'll do one last problem. Okay, so if we're here at the binomial times the trinomial, first take the 4x and pass it out. So we get 8x to the third, careful, that's to the first. Then we get negative 20x squared plus 12x. That's what I get when I pass out the 4x. Now I'm going to pass out the 2. And here's where the stacking helps a little. Look, I'm going to run out of room here. So I'm going to stack. 2 times 2x squared is 4x squared. That's a squared term, so I should stack it under the other squared term. Now, 2 times negative 5x would be negative 10x. And 2 times positive 3 would be positive 6. So usually if you're stacking, it's going to look like a stair step like this. It's going to go 1 over each time. And then we can combine like terms, and it didn't take up like my whole page. So we get 8x cubed, negative 20x squared plus 4x is going to be negative 16x squared. 12x minus 10x is 2x plus 6. I love double distributing. It's so much fun. All right, last one, 2x plus 2, the quantity squared. Now let's fix that plus. The tendency here is to go back to when we were doing monomials. And people want to pass out the 2 to the 2 and the x, but they want to do it here, to the x and the 2. There's a difference between these two problems. This is a monomial. It doesn't have a plus or a minus in it. So when I say 2x squared, what I'm saying is 2x times 2x, which will in fact give me 2 squared x squared. So that actually works in that problem. But in this problem, 2x plus 2, the quantity squared, means 2x plus 2 times 2x plus 2, which requires that you double distribute. So this shortcut method is not going to work if there is not one term, but if there's any more than one term. So if you see any addition or subtraction, you cannot take the shortcut by distributing the exponent. You have to write it out twice and actually double distribute it. Once you know how to do that, or that you have to do that, then it's simple, but you have to make sure you do that. So 2x times 2x is 4x squared plus 4x plus 4x plus 4. Look at all those 4s. Now the 4x squared comes down. The 4x plus 4x gives us 8x plus 4. All right, so that's double distributing. The problems can get more challenging, but they're not going to get they could get longer and bigger. But the idea is still going to be the same basic idea, no matter what.